Hello students, let's start with the next topic of our syllabus, that is nothing but what? Electric potential due to electric dipole. So before starting this, if you remember, in 11th standard already we have learned about electric dipole. Di means two, pole means polarity. So here electric dipole means what? Two opposite polarity together they will call as electric dipole, and it's here in this diagram. If you see at point A there is a charge plus Q. At point B there is charge minus Q. So this plus and minus charge having the same magnitude Q, it will together, this together is said to be electric dipole. Now here we want to find out electric potential at point C, due to this dipole. Let's consider at the center of this dipole is O. Center of this dipole is O. So the distance from OA is L and OB is again L. So distance between the dipole AB is nothing but twice L. Okay, let's consider point C kept at distance of R from O. Let's consider the same point C from charge plus Q or charge plus Q, it is at distance R1 minus Q, it is at distance R2. Then if you see in the diagram I have shown here L sin theta, L cos theta, L cos theta, L sin theta. So as this point C is kept with an inclination theta with the point O or with the electric dipole AB. Now if you find out L sin theta, L cos theta and try to find out this side and this sides, they come to be L sin theta and L cos theta. That's why I have written these values here. In your book they have not mentioned this side as L cos theta, this much. They have not mentioned this much is again L cos theta. But if you do it, it comes to be L cos theta. Now here we want to find out electric potential at point C due to charge plus Q. We will write down first, then due to charge minus Q we will write down then secondly, and then finally we will add these two potential, that will give the electric potential at point C due to this dipole. Okay, so let's start with this. So first of all we write down electric potential at point C due to the charge plus Q, that is nothing but a V1. Okay, V1 equal to, as according to definition of electric dipole, we can write this as 1 divided by 4 pi epsilon 0, 1 divided by 4 pi epsilon 0, Q divided by R1. Charge is plus Q, so it is Q divided by distance from the charge, it is R1. Similarly, you can write down the electric potential at C due to the charge minus Q, that is nothing but a V2 equal to 1 divided by 4 pi epsilon 0. Charge is minus Q, so it comes to be minus Q divided by R2. The distance is R2. So these are the two electric potentials. Just we have find out electric potentials at point C due to charge plus Q and due to charge minus Q. That given by these two equations. So electric potential at point C due to these two charges together, that is said to electric dipole, that was represented by V suffix C. Electric potential at C due to electric dipole together, it is equal to V1 plus V2. It is sum of the electric potential exerted by V1 and V2 together. So we can write this as 1 divided by 4 pi epsilon 0, and Q is common, so you can take Q divided by 4 pi epsilon 0 in the bracket 1 by R1 minus 1 by R2. So this is the equation suppose 1. This is the equation 1 suppose. Just we have written this as a equation 1. We have put the values here and we write this equation as Vc equal to V1 plus V2. Q divided by 4 pi epsilon 0 is common. So bracket, what is remaining? 1 by R1 minus 1 divided by R2. So this is nothing but what? Electric potential at point C due to electric dipole plus having a charge plus Q and minus Q together. Same thing we have done a little bit different way. By the geometrical formula, by using the geometry of this diagram, we have to use some geometrical rules, that is said to be cosine rule we have to use. Basically those who have mathematics, they can know by cosine rule in mathematics or mathematical geometry to this diagram, we can write two equations. One is for R1 square equal to R square plus L square minus 2RL cos of theta, and similarly R2 square equal to R square plus L square plus 2RL cos theta. How this two equation comes? Those who have mathematics, they are well known about. There is a cosine rule in geometry. By that rule we have just written this equation. Those who don't have mathematics, it is better to remember this equation directly. So we have written these two equations. So 2 RL cos, here it is minus, here it is plus. So that is the difference only. Now here, remember, apart from this, just we have to take right hand side, r square common in both the equations. So we can write r1 square, r square is common. So what is remaining? 1 plus L square by R square minus 2L divided by R into cos of theta. That is R1 square. Similarly, R2 square is taken common. 1 plus L square divided by R square plus 2L divided by R into cos theta. So we get these two equations by taking R square as a common. Now here question comes that as R is very much greater. So if you see in the diagram, this R, this distance R from O to C, it is very much larger than the L. So we can say as R is very much greater than L, L square divided by R square is very small, So we can neglect that term in both the equation. We can rewrite the same equations as R1 square equal to R square in the bracket 1 plus twice L by R cos theta and R2 square equal to R square in the bracket 1 minus 1 is R1, it should be the minus, so it should be minus R2, here it is R2, it is plus. This term is neglected, these two terms are neglected. So if we neglect these two terms, so here it is minus, here it is 2L by R cos theta, it is plus. So we get these two equations for R1 and R2. Further, here if we find out, just here left hand side R1 square and R2 squares we have taken. Suppose I want to remove the square. So just remove the square, take the square root of these two equations and rewrite it. So these two equations we can write it to this side. So just remove the square. So we can write R1 equal to, just take a square root of R1 square, take a square root, R1 equal to R in the bracket 1 minus 2L by R cos theta to the power 1 by 2. Why it's come to 1 by 2? Just remember, if there is a term root x, we can add x to the power 1 by 2. Same thing, just we have taken square root of this equation, so the power comes to be 1 by 2. Similarly, just draw the equation, just take a square root of second equation R2. We can write R2 equal to R 1 plus 2L by R cos theta to the power 1 by 2. So is it clear? Simply we have taken a square root of both, so we can write this. Now just take a reciprocal of both equations. So we can write 1 by R1, 1 divided by R1 equal to reciprocal of this 1 by R in the bracket 1 minus 2L by R cos theta. The power should be minus 1 by 2. Why it should be minus 1 by 2? It is plus. We are taken reciprocal, so it comes to be minus 1 by 2. Similarly, 1 divided by R2 equal to R in a bracket 1 plus twice L by R cos theta to the power minus 1 by 2. Similarly, we have written these two equations. Now, might be you have some question, why we are doing this silly mathematical calculation? The simple answer of this is what? Just if you look at this equation 1, here it is what? 1 by R1 minus 1 by R2 into Q divided by 4 pi epsilon 0. This will give what? Electric potential at point C. Okay, and that's why we want to find out 1 by R1 minus 1 by R2. And that comes here now. If you see it here, let's see. 1 by R1 we get, 1 by R2 we get. Now we have to subtract them and then we'll get here. Just put this 1 by R1, 1 by R2 in equation 1. What we get? Vc equal to what? Q divided by 4 pi epsilon 0. That is common term we have taken. Then 1 by R1 minus 1 by R2 we have to take. So remember here this term get wrong. This should be 1 by R. Okay, because we have taken this as a reciprocal. So here into 1 by R in the bracket 1 by R1 minus 1 by R2. 1 by R1 is this 1 by R in the bracket 1 minus twice L divided by R cos theta to the power 1 by 2 minus 1 by 2. 1 by R1 minus 1 by R2, it is again 1 by R in the bracket 1 plus twice L by R cos theta to the power 1 by 2. So we get this thing. Now 1 by r is common in both, so take it common outside. So you can write q divide by 4 pi epsilon 0 into 1 by r as common. Inside the bracket, what we can write? We can write these terms. So here, before writing the term, there is one mathematical equation in mathematics. There is one equation, 1 plus x to the power n. Binomial expansion theorem is in mathematics. 1 plus x to the power n equal to 1 plus nx. 1 plus nx binomial expansion if x is very small than l. X is very small than n, we can write down this equation. Same way in our case, L is very small than R, so we can write this expansion 1 plus nx. In this case, what is n in our case? Minus 1 by 2. If it comes here minus 1 by 2, minus becomes plus. 2 get cancelled out. So what we can write? 1 by R already we have taken. What we get in first box? 1 plus this minus 1 by 2 comes, 2 get cancelled out. L divided by R cos theta. 1 plus L by R cos theta. This is the first bracket. Minus 1 by R already we have taken. Second bracket, 1 plus again, here it is minus 1 by 2. Here minus 1 by 2. Minus 1 by plus 1 by 2, it should be minus 2 get cancelled. L by R cos of theta. So we get these equations as according to binomial expansion theorem. To the first approximation, just we have taken a L by R term, L square by R square term we have not taken, so we get this equation. Is that clear to everyone? I hope that all of you got this terms. Is that? Now let's see, if we just solve this, just remove the bracket. So this bracket we have removed internal bracket, it remains same. Minus comes to be minus 1, it comes to be plus 1. Minus 1 plus 1, this plus 1, minus 1 cancelled out. So what we get here? Q divided by 4 pi epsilon 0 into R. L by R cos theta plus L by R cos theta. 2L divided by R cos of theta. We get twice L divided by R cos theta. So twice L cos theta divided by R, or twice L by R cos theta. This R become R square. Q into twice L. There is one term. That is nothing but the momentum. Electric dipole moment represented by P equal to, the length is nothing but a twice L and charge is nothing but a Q. Q into twice L is nothing but what? One term represented by P here. Q into twice L is term represented by P, and that is said to be electric dipole moment. So we can put that equation here and we can write this as P into twice L. Q into twice L is P. So we can write same equation. 1 divided by 4 pi epsilon 0 P cos theta divided by R into R is R square. That is a VC. VC is nothing but what? Electric potential at point C. P cos theta divided by R square. Same thing can be written in different a little bit. So we can write this as 1 divided by 4 pi epsilon 0. So P cos theta, here it is term. So we can write this as P dot R, vector P dot R is nothing but this divided by R cube. Now question comes, this R square, how it comes to be R cube? Where is the cos theta? It's very simple. Dot product, if you know the definition of dot product, P dot R is what? P R cos theta, out of which P cos theta is here, R is extra then that was here in the denominator R cube. So we can write this like this. Same equation further they have written in your book in different way. Just I will write down in front of this. So what they have written in your book? 1 divided by 4 pi epsilon 0 P into R cap divided by R square, where R cap equal to vector R divided by R. So again we have removed one R and numerator R comes in terms of R cap. So this is the equation which will give the electric potential at point C. Now further there are two cases. Let's start with the two cases here. So let's start with the first case. Let's start with the first case. When theta equal to 0 or 180 degree. When theta equal to 0 or 180 degree. What is the cos of 0? Plus 1. What is cos of 180? Minus 1. Then what we get? Vc equal to plus minus 1 divided by 4 pi epsilon 0, 1 divided by 4 pi epsilon 0, p divided by r square. Because cos 0 is plus 1, cos 1 it is minus 1. This is the value of the electric potential when theta equal to 0, means it is along the axis. So sometime this is also said to be v axis. Why it is said to v axis? How it would be v axis? Let's see the diagram. If we see this diagram, if this theta is 0, point C comes on this axis, that is said to be axis of electric dipole. So that electric potential is said to v axis. If theta is 90, it exactly perpendicular like this 90, that is said to be equatorial. Same, that is the case second we have to consider now. Let's start with the case second then. In case second, that is second condition, so it is v axis. Second, theta equal to 90 degree or 270 degree. What should be cos of 90? It is 0. So Vc equal to 0. It is said to be V equatorial. V on equatorial axis is always 0. So electric potential has minimum value when theta is 90 degree, that is on equatorial line, and electric potential is maximum on axis, its value is this, minimum on equatorial, its value is this. So this is nothing but what? Derivation of electric potential that we have derived here. Now let's go to next topic of the same. Electric potential due to large number of charges together. There are large number of charges, n number of charges. What is the equation for electric potential that we have to derive here? So what should we do? So electrostatic potential due to system of charges. So just I will write here electrostatic potential due to system of charges. System of charges means what? There are large number of charges and we want to derive the same equation for electric potential. What would be the equation that we have to do here, that we have to derive here? So let's consider there are n number of charges represented like this, 1, 2, 3, and suppose here is this charge q1, here it is charge q2, here it is charge q3, kept at a distance of r1, q1 kept at r1 from p, q2 kept at r2, q3 kept at r3, so on up to qn charge, nth charge kept at distance of rn from a point p. Now here our aim is nothing but what? To find out electric potential or electrostatic potential due to this n charges. So first of all, electric potential due to charge q1 at p is suppose v1. Due to charge q1, electric potential is v1, q2 it is v2, q3 it is v3, qn it is vn. Now write the equation for electric potential at point P due to charge q1. So we can write v1 equal to what? Just 1 divided by 4 pi epsilon 0, 4 pi epsilon 0, q1 divided by r1. It comes to be q1 divided by r1. v2 1 divided by 4 pi epsilon 0, q2 divided by r2. Electrostatic potential exerted by Q2 at P. Similarly, v3 equal to what? 1 divided by 4 pi epsilon 0, q3 divided by r3. So on, vn equal to 1 divided by 4 pi epsilon 0, qn divided by rn. So all these charges exert a potential at point P, v1, v2, v3, so on up to vn. So what is the total potential exerted by all these n charges at point P? According to principle of superposition of wave, that is suppose V, total potential exerted by all remaining charges, it must be sum of the charges exerted by Q1, V1 plus Q2, V2 plus so on up to n number of charges. So add all these things. So 1 divided by 4 pi epsilon 0 is common. In the bracket, Q1 divided by R1 plus Q2 divided by R2 plus so on up to plus Qn divided by Rn. So this equation gives the electric potential due to n number of charges acting at point P. So this is the simple equation we have derived for system of charges or n number of charges. They are exerting some electric potential. Same thing can be written as 1 divided by, I will show it. Just we have to just use the 1 divided by 4 pi epsilon 0. This can be represented by summation Qi divided by Ri. I varies from 1 to n. So this is again another form of same equation. Okay, now let's go further. The next topic in your syllabus is what equipotential surfaces. This year this topic is eliminated, so we are not going into detail of this. Next one is what electrical energy of 2-point charges and dipole in electrostatic field. Electrical energy means what? Electric potential energy we want to derive in this case. So let's start with this topic. Some of the two topic will finish, and the remaining topic we'll see in the next video. So let's start with the first. Electric potential due to the charge of 2-point charge system. So before going in detail, here in the book, if you see, they have the bold lines, 4 bold lines that will give the definition of electric potential energy. So just we will revise it. Electrostatic potential energy of a system of point charges is defined as total amount of work done to assemble the system of charges by bringing them from point of infinity to present location. If you remember, already in first video we have learned electrostatic potential energy is what? The amount of work done required to move the charge from infinity to the given place. How much work done is required? That work done itself is said to be electrostatic potential energy. So let's start here. Electrostatic potential energy of system of 2-point charges. Electrostatic potential energy of 2-point charges. 2-point charges. Electrostatic potential energy of 2-point charges. 2-point charges means what? There are 2 charges. Due to these 2 charges, how they will exert electrostatic potential energy, that we have to find out. Let us consider this 3-dimensional coordinate system whose origin is at O. Let us suppose 4 charges kept here at point A. The charge kept is Q1 or plus Q1 we can say. The another charge is kept at point B. Suppose this is point B where the charge is kept as plus Q2. As both are plus, there must be repulsion. Now just connect these 2 charges from this origin and we can get here this as Q1 and this as Q2 kept at distance R2, Q1 kept at distance R1 from a origin. Now let's go to the distance I have drawn here in between A and B. It is the distance R12. Distance R12 between the 2 charges. Now here under this type of thing, when suppose both the charges Q1 and Q2 kept at A and B, they are at infinity somewhere. Suppose they are here. Q1 is here and Q2 is here at infinity. They are not shifted here. Nothing is here in this system. Initially, when we take a charge Q1, move it to the system at point A. As in the system there is no any charge, there is no any work done required. Why does not require work done? Because here there is no opposition, there is no attraction, there is no electric field here. That's why work done to bring a charge Q1 from infinity to the point A is 0. That's why we can write here W1 is 0. W1 is what? Work done required to move the charge Q1 from infinity to the point A is 0. Now the Q1 comes here at point A. Now Q2 is at infinity. Now we want to move the charge Q2 from infinity to the point B. Point B is a point where the charge Q1 at A exerts some force. Now we require work done. Why we require work done? Because in this case, charge Q2 is at infinity. When we move it here near to the charge Q1, it will exert a force of repulsion. That's why we have to apply the work done here, and that work done here is nothing but it will create an electrostatic potential energy. So write down here that work done. So first of all, write down that we have to write down that work done to bring it from that. So before writing the work done, just write down the electric potential to bring a charge Q1 from the infinity to the point A. That electric potential is suppose V1 equal to 1 divided by 4 pi epsilon 0 Q1 divided by R1. Q1 divided by R1. It is the electric potential for a charge Q1 kept at A. Now here just we can write here work done required, that is W2 to move the charge Q2 from infinity to the point B in the presence of charge Q1, that is equal to what? Electric potential at P due to A equal to electric potential at B due to charge plus Q1 into charge which is moved. Which charge is moved? Q2 is moved. So into Q2, by this equation we get the work done W2. So put the value, electric potential for due to Q1 is what? 1 divided by 4 pi epsilon 0, this equation. Q1 divided by R into Q2 it comes, so into Q2. So this is the equation, or this is the required work done to bring a charge Q2 from infinity to this. And this work done itself is nothing but what? Potential energy to bring a charge from infinity to the place B. So that can be written as U equal to 1 divided by 4 pi epsilon 0 Q1 into Q2. As these two charges are separated by distance R12, so we have to write here R12. So this is nothing but a potential energy required to bring a two point charges from infinity to the given place Q1 at A, Q2 at B. This much amount of work done is required, and itself it is stored in the form of potential energy. It will be stored in the form of potential energy that was given by this two, due to 2-point charges. Same thing here. If suppose there are n number of charges, just we have listen initial case, electric potential due to n number of charges we have find out. Same way here, electric potential we want to find due to n number of charges. How can we find out? So that we have to see here. N point charges suppose we have, and we want to find out electric potential energy due to n charges. This is a electric potential energy due to 2 charges. Now suppose this is W2 we have find out. Similarly, we can find, suppose imagine that we have introduced another charge here somewhere. Here it is at point C, it is plus Q3. Third charge we have moved from infinity. As third charge we have moved from infinity, so what we get here? We get a work done. Again the work done is would be W1 is 0. For first part it is 0. W2 we have find out. Now W3 would be there. What is W3 then? 1 divided by 4 pi epsilon 0. It is a common thing. 1 divided by 4 pi epsilon 0. This is a common thing that we have find out. So that is nothing but this part of W3 equal to 1 divided by 4 pi epsilon 0. What is remaining? The two charges are already there, Q1 and Q2, and we are moving third one, that is nothing but what? Q3. So we can write here in the bracket Q1 divided by R13 plus Q2 divided by R12. Q1 divided by R13 into plus Q2 divided by R23. Not 1, 2, it is 2, 3. Distance from first charge to third, second to third. Into the magnitude of charge which is moved, it is Q3. So we get this as a work done. If we move this Q3 inside, we can write this equation as 1 divided by 4 pi epsilon 0 in the bracket Q1 into Q3 divided by R13 plus Q2 into Q3 divided by R23, and this will give the work done W3 to move the third charge in the presence of 2 charges. Similarly, if we have again another one charge Q4 at infinity that we have moved at point D in presence of 3 charges, then there is a work done W4 equal to, according to this, 1 divided by 4 pi epsilon 0, that is what? Q1 divided by R14 plus Q2 divided by R24 plus Q3 divided by R34. Outside the bracket charge move is what? Q4. Again, if you solve it further, what we get? 1 divided by 4 pi epsilon 0 as it is. Q4 move it inside. Q1 into Q4 divide by R14 plus Q2 into Q4 divide by R24 plus Q3 into Q4 divide by R34. So in this fashion, this is work done required to move the fourth charge in the field of third charge. Similarly, we can write in general equation to move the n number of charges from infinity to this. What is the potential energy? This work done itself is nothing but a potential energy. So write down the equation for potential energy. U equal to 1 divided by 4 pi epsilon 0. This is the potential energy to move the n charges from infinity to the given point. 1 divided by 4 pi epsilon 0 summation of qi qj divided by rj into k, rjk. So here suppose j equal to 1, k equal to 4, 1 4 divided by 1 4. In this fashion, 1 4 1 3 1 3 divided by r13, so on. In this fashion we can find out the total internal energy. So here summation for what? All pairs of J and K, all pairs of J and K, and this equation give the total potential, electrostatic potential energy to move the n charges from infinity to the given point. I think it is better to stop here today. Next period we will see potential energy due to single charge, then the potential energy due to system of two charges in electric field, then the potential energy due to dipole, electric dipole in external field, that we will see in next period. So I hope you understand whatever I have taught you. If you don't understand, try to watch my video. Just try to understand the topic in my video and just try to read the same topic from your book. Definitely you get a better understanding of the topic. Let's see in the tomorrow with a new video. Thank you.